So hello class. I'm recording all these videos on the same day, so if you're wondering why I'm wearing the same thing and look exactly the same, I'm recording these all on the same day. This is for Wednesday's class, and it's called slope fields. So we're going to talk about something completely different than everything that we've done before. Um, I guess for all of calculus. So yay, something new. Okay, they're called slope fields. So when I was with you guys on Monday, we talked about solutions to differential equations. Okay, this is an example of a differential equation, if you guys remember. A differential equation is a dy dx, or a derivative, equal to some function with a y and an x. Okay, so normally when you take a derivative, like the derivative is equal to 2, or the derivative is equal to 2x, or ln of x. But if ever you have a case where dy dx or derivative equals a function that has a y and an x, that's called a differential equation. What's confusing, or where I might lose you, is that a slope field is drawing the answer to what we did. So you may remember doing these problems on Monday. I know some of you, like Francis and Sean, and who else was there? Mabel. You guys got this and picked it up very fast. This is how you graph the answers for these types of problems. So remember doing something like this dy dx over x equals negative x over y. Okay. This question says draw a slope field. Okay. Sorry for coughing. I know Donnie hates that. What I'm going to do is essentially I'm going to draw a graph. Okay. For this activity, I mean you could do it for any. Just like remember when you graphed, you could use like any numbers. What I'm going to do is I'm going to use all numbers from negative 2 to 2, and on the y-axis, all numbers from negative 2 to 2. Okay. So what I'm going to do is I'm going to list every coordinate available in this graph, because I'm going to graph it just in a small, tiny window from negative 2 to 2. Okay. So starting from, I don't know, let's start from this negative 2. I could have a coordinate of negative 2 and 2, right? I have this coordinate. I'll even draw a dot. I could have a coordinate here. I could have a coordinate, like, I don't know if I could draw exactly on the, there's a point here on the x-axis. There's a point here, and there's a point here, right? So I'm just graphing every coordinate available in this one. And you might agree that there's a point here, there's a point here, there's a point here on the axis, there's a point here, there's a point here. There's a point on the axis, point on the axis, point on the axis, point on the axis, point on the axis. Point here, point here, point on the axis, point here, point here. Point here, point here, point on the axis, point here, and point here. So maybe you could draw for me real quick, and if you need to pause, draw for me a set of axes from negative 2 to 2, and every possible coordinate, well I mean, there's more coordinates here, but on the main numbers of each of them. What I'm going to do in the table is I'm going to write each of those. So at the negative 2, I have these ones, right? Agree? And then on the, if I move over to the next one, negative 1, oh, I'm going to run out of space. Oh, that's okay. Oh, sorry, this should be negative 2. Negative 1, 2, negative 1, 1, negative 1, 0, negative 1, negative 1, negative 1, negative 2. Okay, so I'm just writing it all down. And actually, even though I run out of space, I'm just going to show you the basics of it, and then I think you guys can get it. And then on the in this row right here, I have 0, 2, 0, 1, 0, 0, and there's more. I didn't get to these, but you'll get the point of it. Okay. So first of all, just to repeat in case you got lost, for slope fields, you need to define a window. And then for this class, I guess I should have made it smaller, but for now, from negative 2 to 2, and I wrote down every single coordinate that is possible in that window from negative 2 to 2. So I wasn't able to list them all, but here are most of the possible coordinates available. Now, if x is negative 2 and y is 2, I'm going to plug that into my differential equation. What does that make dy dx? So if I put negative 2 here, okay, and I put 2 here, so I put negative 2 and 2 into this right here, I'm going to get, this becomes a positive 2, and 2 over 2 is just 1, right? Okay, so far? If I do negative 2 and 1, negative 2 divided by 1 is negative 2, and then negative and negative 2 is 2. Negative 2 over 0, you'll notice that if I divide by 0, that's undefined. I don't know how to write it in this. I'll just cheat. Oh. Undefined. Okay. If I plug in negative 2 and negative 1, negative 2 divided by negative 1 is 2, and then I have this negative out in front. Negative 2 divided by negative 2 is 1, and then I have this negative out in front. So you can see what I'm doing. You might see a pattern. You may not see a pattern, but what I'm going to do is I'm just going to fill in the rest by plugging it into here and seeing what number I get. Negative 1 over 2 is 1/2, and then with the positive, I get a positive 1/2. Negative 1 divided by 1 is negative 1. With the negative out in front, that negative 1 turns positive. Here we go again. Dividing by 0 is illegal, so undefined. Negative 1 divided by negative 1 is 1, then a negative out in front. Negative 1 divided by negative 2 is 1/2, and then I have the negative out in front. These are all easy, actually. 0 divided by 2 is 0. 0 divided by 1 is 0. 0 divided by 0, a little bit trickier, but undefined. So hopefully you guys understand what I do here. Okay. Then what you do is you're going to graph this. Okay, and you might be confused. How do I graph this? Okay. At the point negative 2, 2, I need to graph a slope of 1. And remember, just a little side note. Here's a little cloud. Something with a slope of 1 is just like a straight diagonal line, right? Something with a slope of 2 is like a little bit steeper, right? And something with a slope of like negative 1 is like in the other direction. Okay. Essentially, what I'm going to do is I'm going to draw the slope on each of these points, depending on what I got in my table. So at negative 2, 2, which is right here, I'll use a different color. At negative 2, 2, I need to draw a slope of 1. And you can't be exact, but that is a slope of 1 right there. Okay. At negative 2, when I have to draw a slope of 2, remember it's a little bit steeper than this. So I'll draw, see, I'm not that good, but I'll draw one that's a little bit steeper. Okay. And then wherever it's undefined, what you're going to do is you're going to draw a straight vertical line. And this one already has a vertical line on here, but like so. And then yours will be a little bit neater. I'm actually on the point. It's just that mine is, I'm doing it on this computer, so it won't let me draw exactly on it. At negative 2, negative 1, it wants a slope of negative 2, so I need a steep slope going in the opposite direction. And at negative 2, 2, I want a negative 1 slope, which is just a straight diagonal, but in the opposite direction. So do you see how I drew? So I took this right here, and I drew the slopes right here. Okay, just to make it a little bit more quicker, negative 1, 2 is a slope of half. A slope of half means it's like positive, but it's going slower. So like so. Negative 1, 1 is negative 1, 1 right here is 1. Oops. Again, it's really hard to do this on a computer. Negative 1, 0 is undefined. Remember, undefined is a straight vertical line. Negative 1 is also negative 1, so it's a negative diagonal line. And then negative half is a slower diagonal line, so. So remember, it's hard to do it on here. It's hard to be even exact anyway. 0, 2 is 0. Remember, a slope of 0 is a straight horizontal line. I can't draw it on here, sorry, on this computer, but a straight horizontal line looks like that. This one's also 0. 0, 0 is undefined. And then if I do all these two also, that would be 0 and 0. So if I had to draw this, let me redraw it for you. It should look like this on your paper. And again, it's not really exact, but And then if you did the rest of them, like if you did the ones, you'll see this pattern. So when I draw these, and again, you can do this for some. Do you guys see that pattern? It sort of looks like a circle, almost like a ripple in a pond. That is the slope field. That is the solutions for this differential equation right here. And all you have to do is they just want you to describe it. Okay. So describe the points next to it where all the slopes are positive. You notice all the slopes are positive. You see the slopes are positive here, right? And the slopes are positive here. So all the points, I would say, the slopes are positive in quadrant 2 and quadrant 4. So if I imagine this as a giant x and y axis, it's here in quadrant 2 and here in quadrant 4 where my slopes are positive. Which means in the converse, where the slopes are negative are quadrant 1 and quadrant 3. So in this area right here and this area right here, my slopes are negative. Describe all the points where there's a horizontal tangent line. So do you see here, 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 and here, where my horizontal lines are? So they're all on the y-axis. And it says where are my vertical tangent lines? Here are my vertical tangent lines. Yeah. So I'll put x-axis. And the last thing is like, hey, write out the particular solution with the initial condition of -2 and 1. So this is the stuff that we practiced on Monday. Okay, it might be a while, you might have forgotten. And it's a little bit different. I have this problem right here, dy dx equals -x over y. So let me rewrite that problem. All right, just making sure I wrote it right. Okay, so far? Remember I have to have dx and dy in the numerator, so the very first thing we did was dy equals -x dx over y, right? And what I'll do, I'll multiply both sides by y. Okay, so far? So you notice this one, a little bit easier than the ones we did Monday. Look, they're both in the numerators, and then there's no fractions at all. From this step, you remember, how do I get rid of these dy's and dx's? I took the antiderivative. I'll use a different color. So I'll take the antiderivative of this, and I'll take the antiderivative of this. The antiderivative of y is just half y squared. And the antiderivative of -x is just -half x squared. And remember, I'm going to add they both have a plus c. I'm just going to use the plus c on this side. Are we still okay? Yeah. I'll continue right here. But now that I've solved it, what I did is I use my initial condition. X is -2, y is 1. So if I plug in y as 1, this just becomes half. If I plug in x as -2, -2 squared is 4. 4 times half is 2, and I have this -2. Okay. And if I add 2 to both sides, would you agree that I get like 2.5 or 2.5? Or if I want to combine fractions. So when I add 2 to this side, 2.5 is 5/2. Okay. So now that I found c, all I'm going to do is put this back into my original problem, or the original solution, and then I'm done. Half y squared equals -half x squared plus 5/2. So that is the whole thing about slope fields. I know in your notes and in some of they have this one right here. They have let's say write the equation for the tangent line. Don't worry about that stuff. Okay, just worry about fields for now, this new thing. Use a window of -2 to 2, and maybe you could find some patterns to figure out the rest of them. So normally for a slope field, you usually do some of them, and then you figure out the pattern. Hopefully you guys see that this is the pattern, and maybe some of you say, like, I don't see the pattern. You could just keep on writing more coordinates if you want to, like 1, 2, 1, 1, 1, 0. You could do more coordinates. If you can't see the pattern, I could do more of this table. So the practice problems for today is to do the slope field problems, and then that's it. Remember, just keep it in your packet. You're not going to turn anything in. I'll check it on Monday when I see you guys. So hopefully you guys understand. These videos will always stay on my YouTube channel, youtube.com/mrsalmingo or Mr. Salmingo. So if you ever get lost or confused, you always can go back and watch them again. So thanks for watching. Hope you enjoy.